Okay, so the problem today is missing coin sum. You have n coins with positive integer values. What is the smallest sum you cannot create using a subset of the coins? So we're just trying to find the minimum possible sum that's not being able to create. Input, the first line has an integer n, the number of coins, and the second line is just the coin value of coins for each one. We're supposed to print the smallest coin sum. Okay, 2 times 10 to the fifth, 10 to the ninth. Okay, so we definitely have to use long run in this question because each of our values is 10 to the ninth, and if we have multiple of them, then we're going to exceed the int limit. So we're going to have to use long run in this question for sure. Yeah, I think we see that we have input 5, we have 2, 9, 1, 2, 7. So the first idea is that we definitely have to sort this list. There's no way to go about this. Like once that list coins coin value is sorted, then we can go from the smallest value and look at each coin. And every time we just check up to like a current like number, let's say R, that's our current sum. And up to this point, we can get every value. So then we're just going to look at R plus 1. Does that work out? And then we're going to look at every time, if it does work out, we're going to check that R, like whatever our new coin is less than this value. If that doesn't work, then we know that R plus 1 we can't form. Otherwise, we would have known that we're going to just go to the R plus n, where our next n is our next value. So that everything from R plus n is possible to do. So that's the idea. And it is slightly better than ON because we don't have to go through every value. Whereas we can definitely get the thing we need in a relatively short amount of time because we're just skipping by each one. Okay, let's see the code that we're gonna write. So first we start off with importing the standard libraries, IOStream, Vector, Algorithm, and CMath. That's not today's code. I think today was, I don't have CMath today. Let me go find the code where my code is today. Did not pull it up. Should have been more prepared. Okay, here we go. Because I remember we did not have CMath. Okay, so yeah, our standard three is IOStream, Vector, and Algorithm. And then we have our long because I was thinking, why is that gone? Next, we have our main, which is pretty standard, faster input because our input's pretty big. So we do want our thing to be faster. Okay, we have our in. We're going to input the in. We establish we have a vector. That's a long of our coins. Now what we do is we do input all of the coins on the second line, and then we do want to sort it. That's pretty straightforward. It's just normal standard things. I'm going to set our target to be 1 because that's just our starting point. If 1 works out, that like 1 doesn't work out, then we're going to just return it, and that would be our smallest sum. And if that works, then we do want to increment our target along the way. So we start off at as like we go through an iteration because we have n coins, right? And then next what we do is if our coins, if like the coin at our current index is larger than our target, then we know that we have a problem because if our coin is larger than that, then that means that there must have been a gap and that place is not that target is not reachable. So we're going to return that. Otherwise, we know that it is reachable. In the case that it's reachable, we would just update our target to be the coin value added to it, current value plus coins at that coin added to it. So then in the end, we would just get our target, return our target, and then cool, we get what we need. I think this question, the major difficulty is thinking of this greedy algorithm where mm, it's the first intuition is the stupid, dumb way of just brute forcing it, like checking every value, like 1, 2, 3, 4, all the way till n. But realistically, because there is a big sum, like let's say it could have been 10 times 10 to the fifth times 10 to the ninth. That is way too big for us. So we definitely have to be smart about it. And we just have to think everything in the front, like we know up to this point is possible. So that if it's smaller than that, and we add that area, add that section to it, then it would still be possible. Whereas if like our thing is larger than that, then there must have been a gap between our current possible all the values versus right now that value. So there must have been a gap in between the spot. So then our smallest one would be just that target plus one. But because we set our target to be what we need and target is not hittable because the coins is not there yet, then we would have just returned target. So it's just different implementations of the same idea.